of density rho. Let H be the, on the left hand side there's a liquid. Here everything, this is air. So what force? And it is hinged here. So this is a hinge. So this is free to rotate about this axis, about the hinge. So what force I should apply? External force, so that what happens? It will not rotate. And what is the reaction at the hinge? Neglect atmosphere, P naught equal to 0. So what is this? This is everything now. So you may, sir, what actually you're doing? This is a rectangular wall. I'll draw the diagram here. So a small diagram will take it so that if it is needed, what happens? This particular wall can rotate about this axis. So who will push that? The liquid. So there's an inch or there's a able to make it out. So for that not to happen, I'll apply external force. So that get closed, and here what happened? Liquid is present. Able to analyze this. So that the width of the gate, let it be B. The same ideas what just now what we discussed here. So this particular wall, it can, the liquid can push it, and this wall is hinged about this particular edge. So the liquid will push it. No? So why the liquid will push? You see, where do this force will act? It will be acting here. It will be acting here. No? So what is the tendency of this liquid? It will try to rotate this wall above the edge 1, 2. And if I make it this a rotational effect here, okay, I'll make it a inch where this wall can rotate about 1, 2. So definitely what is the tendency? It will rotate in this direction. No? So getting the idea, always go for some basic thing like this. So here liquid is there, here air is there. Let's neglect that atmospheric effect. We are not bothered. Okay, no. So what is the external force I should apply? How much of external force I should apply so that the wall should not rotate. The wall should be in equilibrium. Find this, will call it as a gate rather than wall. No, we'll give a name gate. Find the external force acting on gate. For equilibrium, the gate is hinged about an axis as shown. I think you have everything in the diagram. Okay, no, go for it. How to bring that one? So what is the tendency of the liquid? It's having a tendency to set up a torque. Am I right? It's having a tendency to set up a torque about what? About the inch. There's a free surface of a liquid. Okay, let me take the small element. And there's a question diagram. Let it as it is. We'll go for it. Yeah. And now the force dF and there's a strip. So at what depth I assumed? At a depth y. The force acting by the force exerted by the liquid on this strip. Shall I say it will set up a torque? So what is the sense of the torque? Will be like this. Then what is the sense of the torque by external force? The external force which is acting will set up a torque in this sense. If these two torques are equal, what happens? The gate will be in equilibrium. How to calculate the torque? First we'll calculate the force. So dF is equal to pressure at that particular thing into area. What is the pressure? Rho Gy. dA is what? B into dy. This is the pressure. This will set up a torque due to liquid. dF into y. About what? About the axis. So rho g y b dy into y. So this will be rho g b y square dy. What should be the resultant torque? Rho g b y square dy. Integrate it 0 to h. So this is torque set up by the liquid. Will I agree this? Rho gb h cube, rho gb h cube by 3. By the torque by the liquid. Who should balance this torque? The external force for equilibrium. No, should be equal 0. So what is the torque by the liquid? We know it. So this will become rho gb h cube by 3 minus f external into h equal to 0. How much of external force? Rho gb h square by 3. I should apply this much of force. Got the idea, no? Please, I think you can hold any book. Some of you are struggling. So it'll be like this, no? The air liquid is present. So this liquid here, what happen? Will try to rotate. So for it not to rotate, there's an inch. I'm holding on top, no? There's an inch. So external force is applied here. The liquid air is having a tendency. You can see that not at one point. The liquid will not exert at one point. Will exert force at all points on the plate. So the liquid is having the tendency to rotate the gate like this. Am I right? So then for not to rotate or pen, I'll apply force here. Is it okay, sir? Can you apply force at any point? Yes, I can apply, but I'm just showing at the bottom here. So liquid air will tend to rotate like this. So that is being kept in equilibrium in this way. Is having, okay, this one here. Is having tendency like this. So here what when the axial force will come. So what is the tendency by the liquid will be in this direction, no? The torque. By the force will be in this direction. So when both the torques are equal, and what is the inch? I'm holding it. I'm holding it. This is the inch. It is hinged about this upper edge. It's having tendency to rotate like this here. About unless, so you must have the imagination. You can't just depend everything on paper. Now, one more thing, I'm asking the reaction. Why the reaction forces will come? I'm not sure. I'm just taking the reaction force like this. Why can't we just equate the force exerted by the liquid on F external? So why we should do here? Because a reaction will also come. So what are the forces that are acting on the gate? Okay, I'll make one small diagram. The liquid will exert a force. So the liquid, what happened, will be exerting a force in this way. Will not be at one point, will be at several points. And the external force is what here? What are the red color arrows? It's a liquid. I'll write it here. And the reaction force is what we are showing it here. It will be really challenging for students to make imagination. You are supposed to do. How to calculate the force exerted by the liquid? I'll write FL. I don't know that value. Let me call that as FL. Can we use the basic formula? What is the total force exerted by the liquid? Force per unit width is equal to area of pressure triangle. I don't want you to calculate again. So force per unit width. What is the width of this? B. So what is the FL? FL should be calculated in this way. Force per unit width equal to area of pressure triangle. Because this is H, no? The width is B. So from this, we'll get it as rho g h square B by 2. No, for equilibrium. For transitional equilibrium, Rx plus F external minus FL equal to 0. So you know F external, you know FL, solve it, you'll get the reaction at the inch. So what is Rx? No. So why can't we equate FL, F external equal to FL? Why we should bring? Check it, these two are not equal. These two are not equal. So therefore a reaction at the inch will come. What is the direction? I'm not sure. Left or right? If FL greater than F external, Rx will come here. If F external greater than FL, the reaction will come towards right. So the Rx direction, it depends upon these two values. We know F external, we know FL, substitute that. Getting the idea? So lot of ideas of mechanics, very less about the fluids. What is the fluids? Fluids is just what, like the liquid is exerted force, finish over. Rest all everything, and the pressure varies with the depth, finish over. The rest all everything is what the mechanics ideas. Most of the questions that comes in exam will be of this kind only. Lot of confusion. You should imagine that particular three-dimensional. It is of like this. So where do you see irrigation projects, check dams? You go, no, don't take selfie there and come. Do make observation. You want to become engineer. Okay, how that check dam, how that gate works. Okay, how if more water comes with more pressure, how the gate will get open. Please notice all this. Because I've seen like most of you, when you go outskirts anywhere, no, somewhere water sources there, if you take rest, if for food, anything, there, most of the engineers nowadays, students, they take selfies and come. They don't want to watch that check dam, how they're able to stop that water, everything. So you just go to the coastal area, you get so many check dams, and they were built some 40, 50 years, 60, 70 years, and still they are working. Still they're working and they're in very good condition, and lot of engineering is involved. I think, you know, Arthur Cotton. I think if any one of you are from Godavari, Krishna, so Arthur Cotton, he was a British, like a officer who is not an engineer, but after looking at the Godavari river, the flow, the terrain, the flat terrain, no, he has constructed. So if you look at the Krishna and Godavari, if you ask Gandhiji, they may say, who is he? But if you ask Arthur Cotton, everyone knows. And everyone will celebrate the Jayanti of him, the birthday, the birth centenary of this particular person. Because almost the two districts, Krishna and Godavari, you go to every part of the land there, water will be available. He just took help of the Krishna and Godavari river, and he has designed, when some 60, 70 years back, at that time there was no heavy machinery like what we have. There was no any heavy machinery, and he has designed with very less pencil, papers available. No, at that time they were very costly. And you look at the way he has designed, no, even till date. So you look at the Google map and search it, no, the way he has took help of the natural flow of water. It's like engineering marvelous. Of course, our thing we don't bother. So next time when you visit, no, Krishna Godavari, or that one, don't along with visiting temples, you do visit all these check dams, everything, no, even the Prakasham barrage. It is built by him only. Getting the idea? It's a engineering marvel. It takes almost 1 week to visit all the barrages, check dams, everything. No, anybody wants to interested in civil engineer. Okay, you must visit Mysore KSR Dam and what we have Godavari Krishna, because these are the like a not at modern, not like PO2